All right. Well, good afternoon, folks. Let's go ahead and let's get started. I just want to make one quick announcement before we get started, and that is on Monday, I'd like us to meet live. So we'll meet live for a little bit, and then I'll let you get to the lesson for the day. But I want to meet to talk about what we'll be doing for the rest of the for the end of the semester. So what I'll have you do and what we'll have to do for the end of the semester. So let's meet on Monday. I'll post the Zoom meeting information again for you on Google Classroom. We'll meet on Monday. I'll talk to you about what the plans are for the end of the semester and what we'll have to do to end the semester. Okay, and then we'll take it from there. Okay, so on Monday, we'll meet live during our class period. I'll take about 5-10 minutes of your time, and then I'll let you go to finish up to watch to watch the lesson for Monday. Okay. All right. So let's go ahead and let's get started with where we left off with yesterday, and we were talking about free falls. Okay. So we were talking about a free falling object, and I defined for you then a free falling object as an object that is falling towards the Earth. Okay. And actually, we define it as falling towards the center of the Earth. Okay. From a position above the center of the Earth. Okay. So any position above the center or above the center of the Earth, if you drop an object and it starts to move towards the center of the Earth, it is in a state that we call a free fall. But furthermore, we define very specifically what the conditions of this free fall are, and the conditions require then that the object is falling, obviously, then that the object is moving in such a manner where we ignore air resistance. Okay, so we got to ignore air resistance because if we have the air resistance, it changes the way that the object moves and it becomes less predictable. Okay. And then we said then, if it is in a free fall, if there is no air resistance, if there's no drag force on the object, then if the only force acting on it is the gravitational force from the Earth on the object, pulling on the object, then the object moves at a constant acceleration, not at a constant velocity. Just to make sure you keep this in mind, it's moving at a constant acceleration, which means that the acceleration does not change. And it's constant non-zero acceleration, folks, because if it's constant zero acceleration, the velocity doesn't change. Here, the velocity has to change because it's being pulled down by the Earth by a force, by a single force. And if that force is acting on it, it will accelerate, the object will accelerate, and if it's accelerating, then it will be changing its velocity. We said then that this constant non-zero acceleration is going to be, it has a value of 9.80 times meters per second squared, okay? And it's always going to be in the downward direction, which is in the direction towards the center of the Earth, okay? So downward will always be the direction of a free fall, okay? All right, for the acceleration, I'm sorry. And so then we said, if those are the conditions of a free falling object, and if the object meets up with those conditions, there are three ways. There are three ways in which an object can fall towards the center of the Earth. And so this is where we left off with yesterday, and this is where I want to start today, because I want to make sure that you folks realize then that even it seems odd to most people who are new to physics and the study of kinematics, how it is that an object can fall in three different manners. Okay? And so we're going to define each one of those manners, and you have to be able to define that to work through the problems involving a free fall. Okay? And so each type of free fall has certain characteristics to them that make them unique. Okay? That makes them unique. And so let's go ahead then, let's review where we left off with yesterday and review each one of the free falls. So we started out with the first type of free fall here. And this is going to be case number one. Okay, this is free fall number one. Okay, and what are the characteristics of an object in free fall in this first type of free fall? Well, first and foremost, and this is going to be the key difference here between this and the other types of free fall, and that is it has a starting velocity of 0. So its velocity is 0. That means then that the object is at rest at the start. Okay? It is at rest at the start. It has no velocity, and then we drop it. Okay, so this is an object that is being dropped, and if it's being dropped, then it has no velocity to start out with. Okay? All right, and so with that said then, the acceleration here is going to be g, and g then is a constant that we give to the gravitational acceleration here on Earth and only on Earth. And we said then that this acceleration is constant and it will always be equal to 9.8 meters per second squared, and it will always be in the negative direction because it's falling down. Remember, falling down then, and this is convention, that downward on the y-axis is negative, up on the y-axis is positive. Again, this is arbitrary. You can switch it around if you want to, but if you do that, you got to make sure you are consistent throughout the problem, keeping the directions the way they are. To save yourself the heartache and the trouble of having to remember that, just we're going to follow convention, and convention, the math convention then dictates in that on a y-axis, negative is down, positive is up, so we'll keep it that way. Okay? All right, so with that, and with that said then, if we can think of the surface of the earth is in this direction here. So we're going to define then the surface of the earth as being downward, okay? Surface as being downward, and that the center of the earth is downward, okay? The object then is moving in the negative direction, so therefore the acceleration is going to be negative. The value then is 9.80 meters per second squared, okay? If you want to use 10, just to make it simple for yourself, go ahead and do so, but the more exact value, and the one I would suggest you memorize, is 9.8 meters per second squared. Now, this value of 9.8 meters per second squared does also vary here on Earth. Okay? So again, this is the acceleration here on Earth. You go to the moon will have a gravitational acceleration that's about half of this here. But as long as you're here on Earth, the value here will be pretty much constant. However, it does change. It changes with altitude. So as you move away from the surface of the Earth, this value gets smaller and smaller. And also as you move toward, and it also depends on the latitude. Okay? As you move towards the center of the Earth, okay, that the gravitational acceleration also changes. But as I mentioned yesterday, you really don't need to know that for this particular class. That is something you really do have to consider as you move on in your physics and your engineering career. Okay? All right, so with that said, then that's what characterizes the, those are the key characteristics of an object undergoing free fall number one. Okay, so this is number one, free fall. Okay, and the characteristics of this particular free fall. So I'm sorry, acceleration there. Okay, I'm sorry, a couple more. We said then that the displacement is always going to be in the y direction, and that displacement will also be negative, and that the final velocity, okay, the final velocity is also going to be negative. It's going to be downward, and we designate this final velocity as the velocity before it hits the surface. Okay? A lot of people think about this and they say, well, you know, if the object hits the surface of the ground, once it hits the ground, isn't the final velocity then going to be zero as well? And so therefore it starts out at zero, it ends at zero. And the answer there is no. The final velocity then is going to be defined as the velocity right before it hits the ground, right before it hits the ground when it still has velocity, when it still is moving. And so we do not want to consider it when it actually hits the ground. We want to consider it right before it hits the surface of the Earth. Okay? All right, so that is how we define then velocity number one. Okay, let's go ahead then and let's take a look at the second type of velocity and what is characteristic of the second type of velocity. And so we said then with case number two, this is free fall number two. With free fall number two, we have then a initial velocity that is not zero. So make sure you keep this in mind. The initial velocity here will not be equal to zero, which means then we have to identify what that initial velocity is. So essentially the way you want to think about it here, and that is with this particular type of free fall here, instead of letting an object drop down towards the surface of the Earth, we actually take that object and we throw it down. So we give it an initial velocity. That's why this initial velocity is not zero. And so this is the key feature that distinguishes this type of free fall from the first type of free fall. Both are moving down. Both are moving towards the surface of the Earth here. So both objects are moving towards the surface of the Earth, which means then they're both moving in the negative direction. Okay? However, the key difference here then is that the initial velocity here will not be equal to zero. Whereas the initial velocity in the previous example, in case number one, the initial velocity there is going to be zero. However, with that said, then everything else about this free fall will be the same. And that is the acceleration will be negative 9.8 meters per second squared. That is, the displacement will also be in the negative direction. And then finally, the velocity final will also be in the negative direction. Okay? Again, this is the velocity right before it hits the ground. So make sure you keep this in mind then that when we talk about this initial velocity here, okay, this is the velocity that is given to an object after it leaves the hand. For example, if you're going to take a ball and you throw it down, You throw it down towards the ground. You don't want to count the, you don't want to measure the velocity as it is still in your hand. This type of free fall, the way we define it, is that it's the velocity that is given to an object right when it leaves your hand. Okay? Right when it leaves the object that is applying the force. So at that point, then there is no extra force acting on this object here. It is moving now at the, it is accelerating as a result of the force of gravity pulling on. Okay? All right, so that's free fall number 2. Okay, so let's make sure you keep that in mind. The reason why I point this out, folks, is when you read and when you work through these problems here, and we're going to do this in just a moment, when you do these problems here, you have to identify what type of free fall the object is undergoing. You have to do that first, okay? Because what will happen is, and these characteristics here, what I'm listing here for you folks, make sure you put it on a flashcard, but however you choose to do it, make sure you memorize these characteristics here, because when you do these problems, the problems will not mention, for example, the acceleration. It will not mention that this is an object in free fall number 2, and therefore it has an initial velocity. You have to remember that. And then what you have to do then is you have to identify that initial velocity. Okay, so make sure you keep that in mind. So you have to memorize these characteristics here in order to get these problems done. Okay. All right, let's move on to the third case of the free fall, which is I think in my experience, the most difficult for people to, new students to physics, to really wrap their minds around, because it doesn't look like a free fall. Okay? The third case of the free fall involves an object, okay, that is not dropped, not thrown down, but that is thrown in the upward direction. This is the third case of the free fall, folks. Third case of the free fall. This is case number 3. Okay, free fall number 3. And this involves an object that is thrown up. It is tossed up in the air. And this is a free fall. And we consider this a free fall. Why? Because remember, we define free fall not as how the object is being thrown, but that it is an object that is moving towards the surface of the earth at a constant acceleration, because gravity is acting on it. Only gravity is acting on it. So do those 3 criteria apply to an object that is tossed up in the air? The answer is yes. First criteria then is that the object is going to move towards the center of the earth. Initially, it does not. Initially, it does not. But we know then that any object that is tossed up in the air, eventually what happens? It turns around and it comes back towards the surface of the earth. So this is the first criteria is met up with, and that is eventually this object here that is tossed up will eventually move towards the surface of the earth. Second condition, is this object then moving at a constant acceleration? Yes, it is. Okay, if this object then is moving moving towards the surface of the earth, and again we ignore air friction, then okay, then that means that this object has a constant acceleration of negative 9.803 meters per second as it moves up and as it moves back down. Okay, and so this object does move. This object is a free falling object. It is a free falling object, even in its upward trajectory. And so when we define then this particular type of free fall, make sure you understand that you want to break it up into 2 separate parts. Okay? You want to break it up into 2 separate parts. Okay? The upward, okay, so this is going to be the upward trajectory. You want to break it up into the upward trajectory. And then you want to define then the downward trajectory. So what you want to do then is when you deal when you deal with this motion here, this free fall, and this what makes it a little bit more complex, you want to make sure you break it up into its parts. You want to break it up into the part where it's moving up and the part where it's moving down. Okay? Because the key character, so this is identifying this type of motion is simple. Okay, identifying this type of motion is very simple. Solving for it is going to be a little bit more challenging. Okay? However, there are some characteristics that will help us in doing this problem here. And the very first one then is this, okay? That at the very top of the motion, and so an object that is tossed up and then comes back down, at the very top, and if you can imagine, it's going to move in this parabolic manner here. At the top of that parabola, okay, the velocity, and we designate this at the velocity at the height, okay, the velocity at the height, which is at the top of the motion, okay, the velocity at the very top of this motion here is going to be 0. it has to stop. And so make sure you understand that at the very top, it has to stop. Okay. I'm sorry, I had to do that rhyme there. Okay. But at the very top, it has to stop because it's going to turn around and come back down. Okay, there's another rhyme for you. I'm on a roll here, folks. So you have to put up with me. Okay, if more of them comes out, then too bad. You have to sit and listen to them. Okay, but there it is. So you have then an object that has to turn around, and then as it turns around, it has to come back down. An object cannot turn around and come back down unless it stops. So the velocity, and that's what characterizes this type of motion here. And that's the first thing you want to make sure you keep in mind then is at the very peak, at the very apex of this motion here, the velocity is going to be 0 meters per second. Okay, and so that'll help. Okay, all right. So with that said, then let's go ahead then and define then the downward as being negative and the up as being positive. Okay, so let's go ahead and further characterize this motion here. Okay, so first and foremost, then this object then, in order to be tossed up, so let's focus on the upward trajectory first. Okay, in order for the object to be tossed up, it has to have an initial velocity. Okay, the initial velocity here will not be 0. It can't be 0. It's not going to start and stop. Remember, the idea here is then is that it as it's tossed up, okay, it's the velocity as the object leaves your hand. So you're going to throw a ball up in the air. If you throw a ball up in the air, this particular free fall then takes into account the object as it leaves the hand. So it has a velocity that's not 0, but that velocity will be in the positive direction. This initial velocity here is in the upward direction. And remember, we define upward as being positive. So this initial velocity will be positive. Okay? So that's going to be the upward trajectory. Remember, when we deal with this type of free fall, break it up into the 2 separate motions, the upward motion and the downward motion. We're focusing on the upward motion first. Okay? The displacement in the upward trajectory, the displacement then will be positive. It will be positive because it's moving upward. Okay? However, okay, and keep this in mind, the acceleration will always be downward. So the acceleration here will be negative 9. The acceleration will be negative. And I think this would make sense for you, okay? It will make sense if we talk about it in just a moment. The acceleration then will be negative 9.8 meters per second squared. So in the upward trajectory, the object has a positive velocity. Okay? It has a positive displacement, but its acceleration is negative. Does that make sense? Absolutely. Because understand this, folks, when you toss an object up, what does it do? It doesn't speed up, it slows down. And again, if you don't believe me, you go out. You can test this on your own. Go outside, throw a ball up in the air. It starts with a certain velocity, but it has to slow down. It has to slow down so it gets to the point where it stops. Right here at the top, that's stopped before it comes back down. Okay, so therefore, as the object is moving up in the upward direction, it slows down. Okay, and if you look at the signs, okay, if you look at the signs here, the velocity is positive. The acceleration is negative. We learned this back a couple weeks ago. When those two are in the opposite direction, the object is slowing down. So there it is in the upward trajectory. The object has to be slowing down as it moves upward. Okay. All right, let's go ahead and take a look at the downward trajectory then. That means then as it starts this downward path here, okay, so right after it leaves this height, right after it leaves this peak here, it's going to have a velocity initial that is not equal to 0. Okay. Again, this is taking into consideration the downward trajectory. That is, after it reaches this peak, immediately, as soon as it starts moving back down, it's going to have a velocity that is not 0, okay, but it will be negative. So the downward trajectory is going to be negative. Okay. The displacement then will also be in the negative direction, okay, because it's moving down now. And then finally, the acceleration, which is also still 9.8, will also be in the downward direction. Okay, and so if you notice then, the acceleration doesn't change here, folks. The acceleration stays exactly the same, and it has to. Remember, this object is in a free fall. And so if it's in a free fall, the only force acting on it is gravitational force. And if that's the case, then the gravitational force is always going to be negative. It's always going to impart an acceleration that is negative, and it will have a magnitude of 9.8 meters per second squared. And so the acceleration here never changes. Okay? The velocity changes, folks, okay, but the acceleration has to always be the same. And if you notice here, it is the same. And so what this object does is that it speeds up as it moves downward. Why? Because, folks, here, we understand it reaches the top, and then once it reaches the top, it has to start speeding up as it moves back down. And we see here also then that the velocity and the acceleration have the same sign. It's a negative and a negative, and therefore it's going to be speeding up as it comes back down. So the object slows down as it moves up. It speeds up as it comes back down. This is the third case of the free fall, folks. And this one is not as simple to understand and to remember as the previous two. But if you work out these problems, you're going to realize then that this becomes pretty straightforward. And there are other clues that you can use to help you here. Okay, so make sure you understand this. There are other clues that you can use to help you here as you go through this. And that is if the object moves either in a symmetrical or non-symmetrical way. So we're still dealing with the third case of the free fall here. Okay? And I'm running a little low on time here. So what I'm going to do then is tomorrow, what we're going to do is we'll finish up and we'll talk about the two ways that an object can be tossed up and then comes back down. It can move in either a symmetrical manner or an asymmetrical manner. In that case, then once you identify that, there's a certain way, if you can identify it, it's going to help you solve those problems a little bit more. Okay, so we'll work on that tomorrow, and we'll start working out some problems involving free fall here. And then I'm hoping that we can go ahead and get started with two-dimensional motion and projectile motion. And then we will eventually get to that PET lab that I was hoping that we can do. Okay, so good. So hopefully, if you have any questions of this combined, see me if you want some clarification. Okay, unfortunately today I can't meet with you, but I will be available for office hours tomorrow. Okay, all right, folks. I will see you tomorrow in lecture. Have a good day.